So we go over conic sections once again. So this is the follow-up video from the previous video that we did, where we are finding the equation of the circle from using the general formula. So in this method, which I've called M2, we are going to use a different method. So one of the key points that we need to keep in mind as we use this method of like making a sketch of what we have is that we need to find the center and the radius. Of course, in the previous method that we used, we were able to find the radius, and the center was not really, it was not really relevant for us to find the center. Yeah, but in this case we need to find the center and the radius. And one of the facts that we have to know is that the center of the circle will always lie on the perpendicular bisector. Okay, that's just a geometric fact or geometric principle that we have to remember always. And the perpendicular bisector is always half of the chord. So the midpoint of the chord is where you're going to find the perpendicular bisector. And it's also important that from the points that you're given as you make a sketch, you need to ask yourself to say or check, do you have a vertical or horizontal chord from the points that you're given? So from the sketch, I believe we'll be able to tell whether or not we have a vertical or horizontal chord from these points. Okay, so just going to make a small sketch um, to see. Okay, so that's the XY plane, like that. So this is our y-axis and this is our x-axis. So the first point that I have is that I have 2,3. So I'll say, maybe let me say this is my 1 and this is my 2, this is my 3. Then in the y-axis I have 1, I have 2, I have 3 here, I have 2,3. So let's say maybe the first point is somewhere here. Okay, like that, somewhere there. Then we have also 3,2. We have 3,2 here, like that. Okay, we have 3,2. Then the other one we have negative 4,3. So we have negative 1, negative 2, negative 3, negative 4. So we say it is somewhere here. The point is somewhere there, like that, roughly. But of course, if you're using a graph paper, that would be much precise compared to what we have. So what we do here is that we're able to what we do is that we know to say the circle is passing through these points, and we can roughly say that it can be something like this. Okay, something like that. But of course, as you do it with your compass, this will be much better compared to mine. Okay, something like that. So what we need to do here is that, remember, I spoke about asking yourself, do you have a vertical or horizontal chord from the points that you are given? So I've found out to say so in fact, to make my work much easier, let me name this as my A. Okay, then let me name this as my B, then this as my C. So meaning this is A, this is B, and this is C. So I've seen to say I have a horizontal chord between point B and what? Between point B and A, which is that one, like that one there. That's a chord like that. So what do we do from that chord? From that chord, we need to find the perpendicular bisector. And what we do here is that there are two ways in which you can approach this. You can either use your compass, and it's more like you open your compass more than half of AB. You're going to put an arc here, an arc there. You go on the other side, an arc like that, and like that. Then you put a line going straight like that. But if you're unable to do that, you can just find the midpoint of this from the points that you have. So whether you use a compass, meaning like a practical way of doing it, or just use calculations, you're still going to get the same thing. Okay, so what I'm going to do is that I'm going to find the midpoint of or AB. So the midpoint of, just say midpoint of AB, of the midpoint of AB is that okay, is equals to, so it's I'm talking about AB, so to be minus 4 plus 2 divided by 2 comma 3 plus 3 divided by 2. So remember to say I'm just using these same coordinates that I have here, that these are the ones that I'm using. So what I'm getting here is that I'm getting minus 4 plus 2 is going to be minus 2 divided by 2 plus, or rather comma, not plus, comma, this is 3 plus 3 is 6, giving us 6 divided by 2, of which we're going to get minus 1 comma what, minus 1 comma 3. So what it is here is that I know this is already a what, a 3. This line is, in terms of y, is 3, and the midpoint of this line is at negative 1, so it's like somewhere here. So what I get is that I've found out to say the perpendicular bisector passes through what, passes through this point, like that. That's what you get. So what do we do then with that perpendicular bisector that we are looking for? So keep in mind to say when you try to find another perpendicular bisector, what's going to happen is that what we know in fact is that the center lies along this line, anywhere along this line. It can be here, it can be here, we don't know yet. So what we need to do here is that we need to find another perpendicular bisector, and where the two perpendicular bisectors are going to be intersecting, that's where the center is going to be. Okay, so what we can do here is that we can use the chord BC, or the chord AC, is up to us, but we cannot use BAB again. So in this case I've chosen to use what? I've chosen to use AC to help me find what, that another perpendicular bisector. This is another chord that we have right here. Okay, so from that chord again, I'm going to find the I need to find the midpoint. Okay, I need to find the midpoint of that of this chord, which is AC. So what we do here is that my AC, so the midpoint, I'm just say MP of what, midpoint of AC is equals to, so AC, I'm talking about minus 4 plus 3 divided by 2 comma 3 plus 2 divided by 2, like that. So this is going to give me minus 1 over 2 comma 5 over what, 5 over 2. So what I've come to find is that the midpoint of this line, okay, the midpoint of this line can be somewhere here. It's on the negative side of the x-axis, but on the positive side of the y-axis. So it's more like we have our perpendicular bisector passing through this point. We just say roughly this point here, something like that. So we should keep in mind to say what we have here. This one here, okay, this is a perpendicular bisector of what? This is a perpendicular bisector of AB. Then this is the perpendicular bisector of what? Of AC. Okay. So and it's also important that we just put the coordinates that we have of the midpoint of AC aside, because we need to use them at some point, because what we have is not really a vertical line or a horizontal line. Is something that has where we need to use the gradient to get whatever that we need from that point. Okay, so now what we need to do here is that remember to say we are looking for a point where we are looking for this point here. So we can't just use guesswork until say, okay, what coordinates are here and here. We really need to use equations for us to be able to understand clearly. And we need to keep in mind is that the perpendicular bisector of AB has the value of x as what? As -1. That is also a fact that we need to keep in mind. Okay, so what we do here is that we need to find the gradient of what? The gradient of AC. From the gradient of AC, okay, we need to get the gradient of what? The perpendicular bisector of AC itself. So we first of all get the gradient of AC. From the gradient of AC, we get the gradient of the perpendicular bisector of AC. And from the gradient of the perpendicular bisector of AC, we get the equation of that perpendicular bisector. From that equation, we are going to replace this value here because it will tell us where those two are those two are meeting, because we are using two equations to find the relationship between those two equations. Okay, so the gradient of AC, we have the coordinates here. We have A here and we have C. To remind ourselves the gradient, we say m is equals to y2 minus y1 divided by x2 minus x1. Okay, so I'm going to use this as my 2 and this as my 1. So my y2 is 3 minus my y1 is 2 divided by, okay, then my x2 is minus 4 minus my x1 is what, is minus 3. This gives me what, this gives me minus 1 over what, minus 1 over 7. So the gradient that I gave is that I get is minus 1 over 7, of which it makes sense that we're getting a negative gradient, because this is more like a retardation kind of thing, like is coming like that, and because a positive gradient is supposed to go like that, and what we have, our AC is more like we have our A here and we have our C here, so it makes sense that we get a negative gradient. So us getting that value really encourages us, because we know that we are moving in the right direction. It could have been weird that we know the line that we have is like it shows negative gradient, but what we get is a positive. So what we do here is that for us to get the gradient of the perpendicular bisector of AC, we just use this small equation, m1 m2 is equal to -1. So our m1 is basically minus 1 over 7, then m2 is equals to -1. So our m2 is going to be what, is going to be 7, is going to be 7. Okay, so our gradients, we have gotten what, we have gotten 7. Okay, so from that gradient now we need to find we need to find the equation of that perpendicular bisector. Remember to say the perpendicular bisector whose equation we are finding is this one here. So we use the equation y minus y1 is equals to m x minus x1, like that. So the m we have, x1 and y1 we have, which is the what, the midpoint of AC. Simple as that. So we say y minus, our value of y is 5 over what, over 2 from the midpoint. Our m is 7. X minus 1 over 2 becomes plus 1 over 2. So this is y minus 5 over 2 is equals to 7x plus 7 over what, 7 over 2. Okay, so we can take this on the other side. This will be y is equals to what, 7x plus 7 over 2 plus 5 over 2. And what we get is that y is equals to what, 7x plus what, plus 12 over 2. So from this equation, so remember to say one of the coordinates of the center we have already found, which is -1 in terms of x, meaning another coordinate that we're looking for is the y coordinate, and we are going to get it from this equation. So how do we get it? We just replace where there's x, we put -1, and we see what we are going to get. Okay, so where there's x in the equation of the perpendicular bisector, we replace with what, with the y, the x coordinate that we found earlier, and that will help us to get what, the coordinates of the center. Remember to say everything that we are doing here, we're just trying to find the equation of the circle. So this is y is equals to 7 minus 1 here, plus 7 multiplied by -1 rather, 12 divided by what, divided by 2. So y is equals to, this is minus 7 plus 12 over 2. So we have 1 here. So y is equals to minus 14 plus 12 divided by what, divided by 2, giving us minus 2 divided by 2, giving us what, -1. So the y value of the center is what, -1. So what we get is that we have -1 comma -1, and this rings a bell because this is the center that we got from the what, from the, after we found the standard form in the previous video that we in the previous video we were using the general formula. So we found that the coordinates of the center is -1 comma -1, and that's all we needed. That's all we needed to get what we are looking for. Okay, so the coordinates of the center is -1 comma -1, like that. Okay, so what we do here is that remember to say the standard form of the equation of the circle is basically x minus h squared plus y minus k squared is equals to r squared. So in this case we don't have the radius. We have already found the center. Remember to say the first point that I said we need to find the center and the radius. So in this case we have the center, which is we have the values of h and k, and for x and y we can pick any point, either a, b, or c. So here in this case we need to find out the radius. So I'm going to pick the point, let me use c. Okay, the point c has 3 comma 2. So meaning my x is 3 minus my h is what? My h is -1, giving me plus what? Plus 1 squared, plus like this. Then my y from point c is 2 minus my k is -1, becoming what? +1 squared is equals to r squared. So 3 plus 1 is 4. 4 squared is 16. Okay, is 16, plus 2 plus 1 is 3. 3 squared is what? Is 9, is equals to r squared. So what we get here is that our r is going to be equals to r squared, rather, is going to be equals to 25. Then the square root of 25 is going to be what? Is going to be 5. And again, what we need to keep in mind is that if someone asks you to say, okay, now we were finding the square root of 25 here, why didn't you use the negative value? When talking about the radius, once again, is that the radius is just the distance from the center to the circumference of the circle. So when talking about the distance, we just pick the positive value. So remember to say the radius, we have found what? We have found that is what? It's 5. So that hence gives us the equation of the circle that we were looking for, and here's how we write it. Okay, so don't replace for x and y, we just replace for h and k. So this would be x plus 1, because that was -1, plus y plus 1 squared is equals to, here this is supposed to be r squared, and what's our r? Our r is 5. 5 squared is what? Is 25. And this is the equation that we got in the previous example where I used the general formula. Yeah, so that's how you go about answering this question using the method where you have to get a graph and use the chords to find the perpendicular bisectors and find where those perpendicular bisectors are intersecting. And just a reminder, once again, if you want, you can use the chord which is BC here. You're still going to get the same thing again. Your perpendicular bisectors will be somewhere here, and even if you were just using your compass to graph and see, you're still going to get the same thing, because here what we have is -1 and what we have here is -1, meaning it makes sense that the calculations and the work that we are doing practically is coinciding. Yes, so that's all from this video. Thank you very much for watching.